Hi, dear students, how are you all? Today, we are going to discuss about one of the easiest and important topic from third chapter, polynomials, which comes from exercise 3.3. The concept is based on relation between zeros and coefficients of the polynomials. This concept is very easy to understand, very simple point, important for bits and 2 marks. Okay, so listen this one. Using this simple concept, we are able to solve exercise 3.3 problems, which are very important, right? Relation between zeros and coefficient for very important two polynomials, quadratic polynomial and cubic polynomial. Let us see. If ax square plus bx plus c at a not equal to 0 be a quadratic polynomial, if it is a quadratic polynomial, and alpha comma beta are its zeros, then the relation between the zeros and the coefficients comes like this. First one, sum of the zeros, that is alpha plus beta is equal to minus b by a. This one is the simple formula. Sum of the zeros equal to minus b by a. And the second point is product of the zeros alpha into beta is equal to c by a. This one is the second relation between the zeros and the coefficients with respect to quadratic polynomial. Is it clear, Nana? In the same way, let us take the next level polynomial, that is if ax cube plus bx square plus cx plus d at a not equal to 0 be a cubic polynomial and since it is cubic polynomial with its degree 3, it may have 3 distinct roots. So, and if those are alpha comma beta comma gamma are the zeros, then we have a relation between these zeros and these coefficients, alpha beta gamma zeros, a b c d coefficients. What were they? First relation is sum of the zeros, directly like this only. Okay, directly I am writing alpha plus beta plus gamma is equal to minus b by a, that is the first formula. And the second one is sum of the product of the two zeros taken at a time, means two zeros taken at a time means alpha into beta into gamma into alpha, product of two zeros sum is equal to, this is also called as sum of the product of the two zeros taken at a time is equal to c by a, this is plus c by a. Okay, this is the second formula, second relation. Okay, Nana. In the same way, third one will be product of all the three zeros, that is alpha into beta into gamma is equal to minus d by a, that is minus d by a. So this one is the third relation between the three zeros and four coefficients of a cubic polynomial. Okay, na? Now see that, Nana, using the previous simple formulas, we can solve exercise 3.3 problems. Among that, very important problems are first bit first and third question, second bit first and fourth question, third bit first and second question, fourth question. These are important problems. Important problems means these are important models for bits and 2 marks, nana. So textbook problems are just reference problems. So using them, we should know the process of doing the solution. That's it. That is the only use of textbook problems. The first question is x square minus 2x minus 8. What is solution? Given quadratic polynomial is x square minus 2x minus 8. They are asking find the zeros of this one first. Then check the relation between the zeros and the coefficients. Okay, this is the given quadratic polynomial. Compare with ax square plus bx plus c. Then we have x square coefficient a value is equal to 1, x coefficient b value equal to minus 2, constant c value equal to minus 8. Clear, Anana? These are the coefficients. To find the zeros, let x square minus 2x minus 8 equal to 0. Take the quadratic polynomial as an equation. It is our choice. Using only polynomial also you can do, no problem. So, but this is the easiest way. This implies select two numbers for factorization whose sum should be equal to x coefficient minus 2, and same two numbers product must be equal to product of the remaining extreme values, x coefficient 1 into constant minus 8. So it should be equal to 1 into minus 8, that equal to minus 8. So we have to search for two numbers for factorization whose sum equal to minus 2, same numbers product equal to minus 8. Such type of numbers what we have, those are minus 4 plus 2. If you add them, you will get minus 2. Same two numbers product will gives you minus 8. So by practicing more number of problems, only you will get the method of choosing the two numbers. Clear about, right? Show this one in rough. Now instead of minus 2 you can split minus 4 plus 2. So instead of minus 2x you can write minus 4x plus 2x. So in this way splitting the middle term gives you 4 terms of the quadratic polynomial. Therefore the next step will become x square as it is, splitted two terms are minus 4x plus 2x, next minus 8 equal to 0. So this is what is happening. Okay, Nana? Right. Now from this 4 terms are there. In this you please observe that from the first two terms you have a term to take common. So here I have x can be taken common, then this is x minus 4. From the remaining two terms you have a chance to take plus 2 common. So don't forget to write the symbol. If it is positive value you need to write plus, otherwise there is no connectivity between the terms to term. Okay, plus 2. For negative values automatically we will write minus 3 minus 7 like that, but for positive values also you should mention the sign. Plus 2 is taking common from remaining two terms, that is x minus 4 equal to 0. So from this step you can check whether you have done the right mathematical step or not, because whatever the brackets you will get they should be same, then only the step is correct, the calculation is correct, otherwise recheck it. Now so these brackets are common, so take them common right side aside, then the remaining value x here plus 2 equal to 0. So x minus 4 is taking common, you can take it left side or right side. Okay, so x plus 2 into x minus 4, product of two terms equal to 0 means then either the first term equal to 0 or the second term equal to 0. Therefore x equal to minus 2 or x equal to plus 4. These are the two zeros. Okay, Nana? Right. So now zeros we have, here coefficients we have. So let alpha equal to first 0 2 and beta equal to second 0 4. Okay, na? This is the solving method. Actually when teacher is giving the full explanation it will take 3 minutes or 4 minutes for the explanation, but when you are practicing it it is taking maximum 30 seconds to 45 seconds only. Okay na? Because these problems are important for either bits or for 2 marks. So save the time properly. Now we got coefficient zeros. They are asking to check the relation between the coefficient zeros. How do we check? According to the formula, two processes are there. Alpha plus beta equal to minus b by a is the sum of the zeros of the quadratic polynomial. We have to check that formula. And alpha into beta equal to c by a is the product of the zeros of the quadratic polynomial. We have to check that one also. Checking means don't take LHS equal to RHS. We have to check whether LHS equal to RHS or not. So this one. So first step, find out alpha plus beta value for checking. Sum of the zeros, alpha plus beta, that is minus 2 plus 4. Okay na beta? That is equal to minus 2 plus 4 is plus 2. Minus 2 plus 4 value is plus 2. Now down under this, find out minus b by a value. So that is equal to b value minus 2. So minus is there in the formula. B value minus 2. Be careful while writing the signs of the coefficients. By a value is 1. This is equal to minus of minus to 2 by 1. That is equal to 2. So left side value alpha plus beta we calculated, we got it as 2, and right side value we calculated minus b by a, we got it as 2. Now we observe that therefore alpha plus beta equal to minus b by a we got. In this model only you have to verify the formulae. Verification means you have to check whether they are equal or not. So find out the first value, then the second value, and observe the thing whether it is equal or not. That is the process. In the beginning only you are not supposed to take these two values are equal, doing left side calculation, right side calculations at a time, because we have to show whether they are equal or not. Keep it in mind. Now what is the second verification? Alpha into beta value, whether it is equal to c by a or not. So find out them separately. Alpha into beta means minus 2 times 4, which is equal to minus 8. Clear? Then c by a value equal to, here c value minus 8 by a value 1, that is equal to minus 8. Here also we observe that both the values are equal. Therefore alpha into beta equal to c by a is verified by our checking process. This is the method, this is the way of verifying the relation between the zeros and coefficient. Clear, Anana? Very easy, very simple to understand. Do many number of problems of the same kind. Clear? Okay, ma. Now you please observe the third problem of this first bit. I have taken third problem of the first bit. They had given the quadratic polynomial as 6x square minus 3 minus 7x. Okay, na? This one. But if you observe this one, they did not given the quadratic polynomial in the general way. Disorder. Terms are disorder. Okay, na? So we need to write the given polynomials in the proper order to do the problem in the easiest way. Okay. So solution, given quadratic polynomial is, rearrange this one as proper way. 6x square minus 7x minus 3. Compare with ax square plus bx plus c. Then x square coefficient, a value equal to 6, x coefficient, b value equal to minus 7, constant, c value equal to minus 3. These are the three coefficients after proper arrangement. Otherwise, simply we will take the wrong coefficient values, total problem will become wrong. So they will try to confuse us. So to avoid that one, please be careful whether they are in proper order or not. Okay, Nana? Right. Now, to find out the zeros, let 6x square minus 7x minus 3 equal to 0. So now try to split the term. For split the middle term for factorization. So we need two terms. whose sum should be equal to minus 7, whose product should be equal to minus 18. X coefficient minus 7, 6 into minus 3 minus 18. Two numbers we have to search. Okay, na? What kind of numbers we have like that? 9, 2, but in this way, minus 9 plus 2, their sum is minus 7, minus 9 plus 2, their product is minus 18. That is the rough work. So now split the middle term, 6x square minus 7x can be written as minus 9x plus 2x, rest of the constant minus 3 equal to 0. Three terms are becoming four terms for factorization. Now, as I told you before, from the first two term, try to take whatever the possible value comes common. So here I can take 3x common. Then it remains 2x from the first term minus only 3 from the second term. And in the same way, from the third and fourth terms, you need to take something common which remains the same bracket. Then only problem correct, step correct, process correct, right? Now, I have only one chance that plus 1 is taking common. It remains 2x minus 3 equal to 0. Clear, Anana? This implies now both the brackets are same, that's why they comes common. 2x minus 3 comes common right side, then the remaining values will become 3x here plus 1 into 2x minus 3 equal to 0. So this is called factorization. From this, let the first term equal to 0 or the second term equal to 0. This implies x equal to minus 1 become plus 1 become minus 1 into 3 will become divided by 3. Or from this, x equal to, this implies x equal to minus 3 will become plus 3 into 2 will become divided by 2. So now let alpha equal to minus 1 by 3 and beta equal to 3 by 2 are two zeros. Two zeros. Okay, Nana? So from the comparison after rearrangement, we got coefficient values. By the factorization process, we got two possible critical values of x according to this equation form. So consider those two values are two zeros, alpha, beta. Now check the relation between them. So already I told you, therefore alpha plus beta is equal to minus 1 by 3 plus 3 by 2. Minus 1 by 3 plus 3 by 2. Okay, this is the calculation. Denominators are not same, make them to their LCM 6. So 3 becomes 6, so into 2 for the numerator, that is minus 2, plus 2 becomes 6 with extra multiple 3, 3 3s are 9. This is minus 2 plus 9 is plus 7 by 6. This is sum of the zeros value. Down, find out b minus b by a value. This is equal to, minus is there in the formula, b value is minus 7 by a value 6. Minus of minus 7 is plus 7 by 6. Both the values are same. Therefore, our first formula alpha plus beta equal to minus b by a is verified. Okay. In the same way, verify the second formula. Now, product of the zeros alpha into beta equal to minus 1 by 3 times 3 by 2. Clear? Denominator 3, numerator 3 under the multiplication get cancelled. This is equal to minus 1 by 2. This is alpha into beta value. Down, find out c by a value. From the coefficient c value minus 3 by a value 6. Now cancellations, 3 times 1, 3 times 2. It remains minus 1 by 2. Therefore, we observe that alpha into beta equal to c by a. That is product of the zeros alpha into beta equal to minus c by a is verified. Okay, Nana? So, in this way, now you see the total time taken is 1.5 minutes to 2 minutes. So, in this way, when you practice more number of problems, hardly in between 1 and 2 minutes, you can solve the problems. Clear? Then we will go through the next model, second bit. Before entering into solve these problems 2 and 3, let me give you one more small concept. That one is how to prepare required polynomial from the given zeros. in the earlier process, if there is a polynomial, we are trying to find out its zeros. Now it's a reverse process. If you have the zeros in your hand, how to calculate its related polynomial? That means if there are two zeros, how to find out related quadratic polynomial? If there are three zeros, how to find out related cubic polynomial? That one I will try to tell you. Right, Anana? Right. So the concept is, if alpha comma beta are the two zeros, then the required quadratic polynomial is k times of x square minus alpha plus beta into x plus alpha beta. This one. This is one of the formula. Okay, Nana? Or another model is there, k times x minus alpha into x minus beta is the second model. Both are representing same, but in two models you should remember, but I suggest the students to do any problem in this model only. This is the benefitable formula to do the calculations easily, right? So now here you just observe that they had given two zeros, alpha beta. From that we are finding related quadratic polynomial, this one. So x square minus alpha plus beta into x plus alpha beta, only this part is called monic quadratic polynomial related to the two zeros. But such type of polynomials can be prepared so many. From the given two zeros we can prepare so many number of quadratic polynomial. So to representing all, we are taking a constant multiple k times of that monic quadratic polynomial. Okay, Nana? Right. So please keep it in mind. Okay, ma. In this second problem, what they are saying, find the related quadratic polynomial if the given two numbers are sum and product of the zeros. So these two numbers are representing sum and product of the two zeros. So how to do the problem? This observation is very important for this problem. Given two numbers, so first number representing sum of the zeros, second number representing product of the zeros. Those are the very important words in the problems we should remember. Solution: if alpha comma beta are the zeros of a quadratic polynomial, then we have sum of the zeros alpha plus beta equal to 1 by 4 and product of the zeros alpha into beta equal to minus 1. These two values they had given. This is the meaning. Hypothesis given data is this. From this, what they are asking? Related quadratic polynomial. Therefore, required quadratic polynomial is k times of x square minus alpha plus beta into x plus alpha beta. That's it. If they are asking quadratic equation, you take equal to 0. So that is equal to k into x square minus alpha plus beta value directly there as 1 by 4 times x plus alpha beta value they had given as minus 1. Since it is negative, I am taking it in bracket. Okay. So this implies k times of, here denominator 4 is there, take 4 as LCM, then it will become 4x square minus 1 time x minus x. Now 4 LCM, 4 into minus 1 is minus 4. Okay, Nana, this one. What meant by k? With these two numbers as sum and product of the two zeros, we can prepare infinitely many quadratic polynomials. Okay, so to represent them all, k value will become 1 or minus 1, 3, 5 by 2, 5 by 6, like that. So for this particular problem, since the denominator is same, for this particular problem, since the denominator is 4, to get the quadratic polynomial in the normal form, let k value equal to 4. Let k equal to 4. This implies 4 times of 4x square minus x minus 4 by 4 will gives you 4 get cancel. That implies 4x square minus x minus 4. Therefore, required quadratic polynomial is 4x square minus x minus 4. Is it clear, Nana? That's it. That much simple. Now see this, Nana. Second problem from this second bit. The two numbers are minus 1 by 4 plus 1 by 4. These two are sum and product of the two zeros of the quadratic polynomial. Then find its value. Okay, that's why given that this is sum of the zeros, alpha plus beta value minus 4, and this number is equal to product of the zeros, alpha into beta. So given that alpha plus beta equal to minus 1 by 4, alpha into beta equal to 1 by 4. Therefore, required quadratic polynomial is k into formula nana x square minus alpha plus beta into x plus alpha beta. This equal to k into x square minus this alpha plus beta value minus 1 by 4 into x plus alpha beta value 1 by 4. This equal to k into 4 is the denominator, so take 4 common, then this will become 4x square minus half minus plus x plus 1, because already 4 is there as the denominator. So since denominator is 4, try to take k value as 4 to cancel them. That is our consideration. Let k equal to 4 to make the polynomial in the regular way. This equal to 4 into 4x square plus x plus 1 by 4. 4 get cancelled. Therefore, 4x square plus x plus 1 is required quadratic polynomial. That's it, beta. Is it clear? Right. Now observe the third problem. Here also they are giving two numbers. But here what those two numbers are representing, clearly they said that find the quadratic polynomial if the following numbers are the zeros of the polynomial. So the two numbers are zeros means solution will become, this is alpha, this is beta, zeros. But here given that alpha equal to 2 comma beta equal to minus 1 are the zeros. We need its quadratic polynomial. Two zeros are there. Na? How to find out? To find out the quadratic polynomial, okay, calculate the sum and product, because then the problem will become little simple to do. So alpha plus beta is equal to 2 plus of minus 1, that equal to 1. Alpha into beta is equal to 2 into minus 1, that is equal to minus 2. Therefore, required quadratic polynomial is, okay nana, k into x square minus alpha plus beta into x plus alpha beta. This is equal to k into x square minus, already we calculated this alpha plus beta value. So instead of calculating here, it is better to calculate here. So that's why I told here. So its value how much? 1 into x plus alpha into beta value minus 2. This is equal to k into x square minus x minus 2. That's it. This is the required quadratic polynomial. Is that clear, Nana? Coming to the next problem of the same model. Here what are the two numbers? Root 3 minus root 3. Solution will become, given that alpha equal to root 3 comma beta is equal to minus root 3 are the zeros of the quadratic polynomial. Okay, you should read the problem very carefully. So to find out the quadratic formula, since I want to use this formula, I need to calculate alpha plus beta, alpha into beta first. Therefore, alpha plus beta is equal to root 3 plus minus root 3. They get cancelled, answer is 0. alpha into beta is equal to root 3 into minus root 3, that equal to minus root 3 into root 3 is 3. So sum of the zeros, product of the zeros we have calculated. Therefore required quadratic polynomial is k into x square minus alpha plus beta into x plus alpha beta. They are asking only quadratic polynomial. Sometimes in the exam they can ask you quadratic equation. If it is equation, you should take equal to 0. If it is polynomial, you are not supposed to take. Keep it in mind. Okay, na beta? Right. This equal to k into x square minus alpha plus beta value 0 into x plus alpha beta value minus 3. This is equal to k into x square minus 3. This is the required quadratic polynomial. Okay na, that much simple problems these are. Okay ma, in exercise 3.3 fourth question models also important for 4 marks. What that question is saying, verify whether the given numbers 1 minus 1 plus 3 are the zeros of the given cubic polynomial x cube minus 3x square minus x plus 3 or not. Then check the relation between the zeros and coefficients. Okay na, that is the question. How we have to do? Very simple na, listen carefully. Solution very easy to understand, normal calculations. Right, given cubic polynomial is p of x equal to x cube minus 3x square minus x plus 3. Therefore at x value 1, polynomial value p of 1 equal to, like 3.1 exercise problems model. Calculate the polynomial value. 1 cube minus 3 into 1 square minus 1 plus 3 is equal to 1 minus 3 minus 1 plus 3. Plus 1 minus 1 cancel, minus 3 plus 3 cancel, answer 0. Since the polynomial value is 0, therefore 1 is a 0 of p of x, we can say. Okay na beta? Right. Now at second x value minus 1, x equal to minus 1, polynomial value p of minus 1 equal to minus 1 into x cube minus 3 into minus 1 square minus of minus 1 plus 3. You need to substitute the value properly. You need to calculate them. Very simple numbers, but don't get confused. Minus 1 whole cube value is minus 1, minus 3 into minus 1 whole square value is plus 1, minus 3 into plus 1 is minus 3, minus of minus 1 will become plus 1 and it is plus 3. Now minus 1 plus 1 cancel, minus 3 plus 3 cancel, polynomial value equal to 0. Therefore we will conclude that minus 1 is also a 0 of p of x. Am I clear, Nana? Now come to the third value. At x equal to 3, polynomial value p of 3 is equal to 3 cube minus 3 into 3 square minus 3 plus 3. Like that you should substitute. Is equal to 3 cube means 27 minus 3 into 3 square value 9, 9 3s are 27 minus 3 plus 3. They get cancelled with plus or minus symbol, polynomial value 0. Therefore 3 is also a 0 of p of x. So first part of the problem completed. For this verification of the three numbers as zeros of the given cubic polynomial, you will get 2 marks approximately. Okay. Now check the relation. So to check the relation, let x cube coefficient a is equal to 1 x square coefficient b is equal to minus 3, x coefficient c is equal to minus 1 and constant d equal to 3 are the coefficients, and these three numbers 1, minus 1, 3 are the zeros. Alpha equal to 1, beta equal to minus 1, gamma equal to plus 3 are the zeros. Okay, Nana? Right. Now, checking the relation. What is the first relation for us? We need to check alpha plus beta plus gamma equal to minus b by a. So, find out them separately. Alpha plus beta plus gamma means 1 plus of minus 1 plus 3 is equal to plus 3. We got its value as plus 3. Now, the next value minus b by a is equal to minus in the formula, b value minus 3. That one separately by a value 1, that is minus of minus 3 is plus 3 by 1, that equal to plus 3. We observe that both are equal. Therefore, alpha plus beta plus gamma equal to minus b by a is the relation between the zeros and coefficients, such as sum of the zeros equal to minus b by a. Verified, both are same. Second relation is alpha into beta plus beta into gamma plus gamma into alpha. Product of two zeros taken at a time with their sum should be equal to c by a. That should be equal to c by a value. So, we need to find out them separately. Okay. So, alpha beta means 1 into minus 1 plus beta gamma minus 1 into 3 plus gamma alpha 3 into 1. Substitute them neatly, calculate them carefully. This is minus 1, minus 3, plus 3. Plus 3 minus 3 get cancelled, its value is equal to minus 1. That is sum of the product of two zeros taken at a time. It should be equal to c by a, na? Calculate c by a. What is c value here? Minus 1 by a value 1. This is minus 1 by 1 is minus 1. Both the values are same. Therefore, our next verification alpha beta plus beta gamma plus gamma alpha came equal to c by a. That is also verified. We concluded like that. Both are equal. Now come to the third step, that is alpha into beta into gamma should be equal to minus d by a. Okay, calculate the first value, LHS value. Alpha into beta into gamma, that is 1 into minus 1 into 3, which is equal to minus 3. Now d minus d by a is equal to minus in the formula d value 3 by a value 1, which is equal to minus 3 by 1 equal to minus 3. Here also we observe that both the numbers are same, both the answers are same. Therefore, we can conclude that alpha into beta into gamma equal to minus d by a. Okay, Nana? Right. So, third relation formula also verified by this. So, in this model, we have to solve this problem. When three numbers are given as zeros, you can verify them whether they are zeros or not, and you can find out the relation between the zeros and coefficients. Okay, Nana? In this model, you can solve the problem in the simple way. So, questions will be different in public examination model. So, practice more number of problems with this simple, easy explanation, get good grade. Okay, Nana? If you believe that this content is useful for 10th class students, if you like the concept, if you like the teaching, don't forget to like, share, don't forget to subscribe. Thank you.